One thing a lot of you have been asking for quite a while is LED boards for the retro consoles. Now, I haven't bothered doing them for a long while because there's been far more interesting projects along the way, as well as being busy. But now, with open sourcing a lot of things I do, I figured this is the best example to get you guys into hardware design. It's about as simple as a board could ever be. There's almost no electronic skill required, and the way to create the board is going to be nice and easy. So what we're going to do is make two boards. The first one is going to be an LED board for the GBA, which is the most popular, and it will light up every single button. So all of the D-pad, the start, the select, the A and the B, the two triggers. We could wrap around and change the LED power button, but for now we're not going to bother doing that. So we'll have a board that sits on the front, or two boards in this case that sit on the front, and light up the console. The first step to this, I always tend to start with the physical circuit board layout, so where we want to fit the components on the board and the requirements of fitting them into an existing design. So for this, I would normally use SolidWorks and parametric modeling, using a vernier to measure all the points on the board, picking a reference point and then measuring away from it, and then modeling up in SolidWorks the 3D model. I can do this because I've got years of experience using SolidWorks, CAD, parametric modeling, and many other things. The problem comes when I want to explain things to people so they can make these boards as well. And I always like to try and find a way to do it for free. So SolidWorks is £3,000 to £4,000 a year. You need experience in modeling, experience in CAD, experience using verniers. There's a lot that you need to learn before you can start. So instead, I spent a bit of time and figured out the best way you could do it for free and with no knowledge. So we're going to look at that today, and the first one is going to be modeling up the actual two circuit boards either side. All this will be open source, so you're all welcome to download the layouts, the code, the electronics files, make the board yourself, sell the board yourself. It's completely and utterly open source under the MIT license. This is the way I'm going to do most hardware going forward, so you guys can benefit the most and learn the most. So let's just jump in and go on the computer and let's see how we're going to design this circuit board. We're going to make it all in this video, and you'll have the actual outline of the circuit board ready. And then after that, all we've got to do is chuck down some LEDs on the board and order it. So it's going to be really nice and easy. You'll be surprised how quick you can do this and how good it will be. So let's just jump straight in and get started. So the way we're going to do this board layout for the GBA is to use board scans. So if you come to RetroSix.wiki, and you can go to, say, the GBA schematics to get the schematic files. We only really need to know a few pins, which is ground and 5 volts. So I will simply tell you these for this design. But if you wondered where I got the S2 pin and the VDD 5 pin from when we come to do this layout, is simply from looking at the schematic. So if you head over to GBA Advanced Board Scans, these are board scans I've done that are highly accurate. These are 600 dpi. But if you click here, you can go over to the GitHub, and if you go into the board scans, these files are the original 3200 dpi, as you can see, 11 megabyte, huge files of the board scans. We don't need them that accurate for this, so we're just going to use these 600 dpi's. So you can just simply right click and save as to save the image. And with that downloaded, the other place we need to go is to inkscape.org to download Inkscape. So you can just go to download current version and then browse to Windows, Linux, Mac, whichever system you're on. Download and install Inkscape. And then let's open Inkscape up. So when you open Inkscape up, you want to go to New Document first if you haven't already. And then we're just going to do File Import. And we're going to bring in the downloaded image we just downloaded from RetroSix.wiki. We're going to link it so the file isn't big, so this will link to wherever you currently have the file on your PC, such as the downloads folder. If you embed, it will actually put that image inside of this image we are making. We're not concerned about doing that, so we'll just leave it as link from file and none for now, and OK. And here's the image file. You can see this is an A4 piece of paper by default, or possibly an American size letter. But either way, it's roughly an A4 size, and we can see a GBA, if it was sat on a piece of paper, would be roughly this size. So we can gather from that we already have the correct scale, as we should do, because this image is already scaled to the exact size of the GBA. And now we have an image we can trace over. So what we're going to do is draw the circuit board around where we want, using this as the true size that we can. So we can happily just draw around and make a circuit board where we want. First thing I want to do is go to Layer, Layers, and let's just make a new layer and call this PCB. And the layer below, if we hide, has got this image on, so we'll call this Image or Scan, and we can lock this layer. So now we can't accidentally click and drag this circuit board outline. So this is now what we're working with. So some basics of Inkscape. I've only used it once or twice myself purposely for this project, just to find something you guys can use. What we need to do is middle mouse and click to pan around, so you can drag around the scene. Wheel, control and wheel up and down zooms in and out. And then right click's your right click menu, left is your selection, and that's it really. That's the basics, all you need to know. So we've done a new layer here called PCB, so if we click onto it, we've got PCB. We can just hide the layers out of the way for now. And then what we're going to do is draw a circuit board around the D-pad, around the start and select, going up to the triggers here, the edge of the trigger to illuminate the triggers. And then on this side, we're going to do the trigger again, and we're also going to do the A and B button. So that's where we're going to put the circuit boards. And it couldn't be any easier really. We just go to the side menu here, and we're going to use this B tool to draw Bezier and curves. And I'll explain something first. So you click around, you can draw basic shapes, and there's a shape. We're then going to use this edit paths by node, and we're going to kind of click and drag and reshape around the circuit as we need to draw circuits in. So that's pretty much how we're going to draw the circuit. We're going to also use the circle tool, so you can hold that control to keep it a perfect circle and shift to scale from center. And we're going to kind of draw around these buttons, say, when we need them a certain size. And then we're going to set fill to none here, and then stroke would be a solid black. And that's how we'd use then the draw Bezier curves and the circle tools to pretty much make all the shapes we need on this board. I'll talk you through it as we're going, but let's just jump in and go for it. So we start with the draw Bezier curves, and I want to really follow this shape so it looks accurate and it's easy to place for the end user. We need to avoid the direct centers here where the conductive pads actually make contact, so we're going to have to put our LEDs just on the rim, and we can measure the perfect size here for the center after, so I'll just put an average size in for now, and then we will measure the rubbers and make sure we're not hitting any of the black conductive pad and tweak that afterwards. But we'll get the general shape in now. We want to pick up ground, which here's a good ground point. So this pad here on the trigger, this is the metal cage of the trigger. So we want to make a connection on here. So we'll curve the circuit board around here so we can solder to this. And then that's a natural point to go up to the triggers. And then we'll pick our 5 volts up here at VDD5. So we need to cover this pad for soldering to as well. Down here, we just need to simply cover start and select. So avoiding those circles, and making sure we avoid all these open holes because they are where plastic comes through. On the right side, we need to do a similar thing. I'm going to trace this shape of the rubber, again, just so it looks cool and it's accurate. And we need to avoid this hole, and then we'll come up to the trigger here. We'll pick ground up here, and for 5 volts this time, the closest pad is this S2, which is going to the cartridge pin, and this is the 5 volt line. The reason we want 5 volts and not 3.3 is because some LEDs break down very close to the 3.3 volt, and when the system's under heavy load, you could be on the limit of the voltage requirements to break down the LED. So 5 volts is a better choice. So that's the idea of what we want to draw. So press B on the keyboard or with draw Bezier curve. We're going to start, say, in this corner, and we're going to go close to the corner, but probably midway. We want to be about, not right on the edge, but I don't know. Maybe right on the edge. No, let's go right on the edge so it looks cool. We just don't want it lipping over too much. So we'll go here. I'm just left clicking now. You can hold control to keep it at set angles. See this little radius here? So this semicircle, this quadrant here, or the arc, however you want to name it. But this radius here, we're not going to draw radiuses in because we're going to add a path effect after to add all the curves. So everywhere you see a natural 90-degree radius, or places such as here, the sharp edge, we can then naturally radius in. We're going to do that after. So it'll make sense once you've done it and seen it once. So for now, I'm going to draw past that. And then what we need to start thinking of as we draw this shape is when we bend the line, what parts we're going to bend. We don't want to go drawing around the shape like this, trying to do a curve. That's not what we want to do. What you want to do instead is put a point at the bottom of the curve, so you can see this natural arc going around here, and you're trying to look at the point at which it sort of stops and stays flat. So you can see it's flat here, and it stops around here. So if we click a point there, and then we go up, and we're going to end the board about here, say, and then we're going to carry on with the board. Now, so you can see what I'm about to do, so it makes more sense, let me just terminate this path for now and show you what the next step would be. The next step would be select the node and then drag in like this. And we'd want to get the curve fitting the shape of the board as much as we can like this. Afterwards, this arc we will radius out. We could also change the size of the path nice and thin so we can see it. So that's what we're going to do on the curves. So whenever you see a curve, you're trying to go to the start and finish point of a curve going one way, and when it changes direction, we start another point. So again, this will probably make more sense once you've done the whole thing once, and the next side you'll be able to see easier. So let's just do that again. We'll go to the B tool, and let's start here now. So close to the edge, hold Control and go up, go to about here, go to about here, and you don't need to be super accurate because we can move and drag these points around as we go. We want to come up to here and curve around here, I reckon, to avoid the plastic clip coming through. So we will give this a little bit of room and come down to about here. We're going to naturally bend this curve in, go to about here and here, and now this big arc, you could technically say in one curve we could come to about here because we can do that big arc there. Sometimes it's better to split these up into two arcs because when they're big and you want to get accuracy, you're best just splitting them. Plus we actually have a breakout here that we want to curve into. So there's a few ways we could do this. We could just draw the circle here now as one arc, which would be nice and smooth, and then draw another path to make this area, and then merge the two together, which is what we're going to do. Otherwise, if we come to this point, so we could go across to the 5 volt, and we add an arc here, the radius of that arc might not be as accurate as the radius of this arc, because it's in one continuous path if we do it in one. And again, to show you multiple techniques, we'll do it this way around. So if we click to around here where the arc stops, let's say somewhere around there, carry on down, and we'll sort of tackle this in chunks. So we'll go to there, we can do a single curve there, we can go up to here. Now we can do this little arc here up to the edge of the circuit board, and then we want up to about here, and then finishing here. So now we have the general shape that looks nothing like the board, but don't worry about that now. Let's just click down here for the stroke path. Let's just make it really thin so we can work with it nice and easy. Maybe a bit thicker than that, a bit thinner than that. 0.05 millimeter. There we go. And now what we want to do, we want to select the End tool, the Edit Paths and Nodes, and let's start forming these curves. So we just have to left click and drag, and then you can see you can drag around. And what I'm looking for at the bottom, see the bottom curve, how it's going sharp. So that's overhanging, that's about level and smooth, and that's sharp again. So we can use a feature called Auto Smooth as well, but you're trying to keep the arc naturally smooth on the edges. So if we keep it naturally smooth on the bottom first, we can only really drag to about here. Then you can drag again and tweak multiple times. And we can move this arc in. We can use the handles if we want to individually move. We can do whatever we like, but that's about accurate. You can click on individual nodes, and up here you will see some options. So you can make selected node a corner, which sharpens it back off, removes this anchor. You can use this auto smooth. So you can see that's done what we wanted, which is to smooth this corner out. And then we could use this to tweak it more accurately into position and smooth once more. So there's little features you can use to make a nice clean path. If we carry on down the line here, we can click to make a rough edge here. We don't want to go too close to this because there's plastic clip coming through. So this edge we're not overly concerned about, but that is a bit too far away. So about there. And then remember, this one will auto smooth to keep it smooth there. This one will auto smooth, because whenever it's meeting a straight line, solid, you want it to be a smooth, transition. You don't want this to be sort of, if I can try and demonstrate it. Say you had the path like this that looks straight. You don't want it to be, say, slightly like this, where there's a little kink when you cut. So that's what we're trying to avoid with the auto smooth. It makes the edges where we want them to be. We'll go to this path here now and drag this curve, and you can see again, we'll take it to the center, then we'll click here and drag again, then we'll click here and drag again, and you can do multiple pulls until you get the shape where you want it. So I'd say there. I'm also going to make this a little bit thicker actually, it's a bit hard to see. So there we go. And you can see now we're following that curve nicely. You can go more accurate, depends how accurate you want to be on the drawing. But I'd say that's more than accurate enough for the rubber shape. Now you see here, this is the point I'm on about. We haven't smoothed this edge yet, and we've got this harsh angle here. So if we click that node and click the auto smooth, you can see what it's chosen to do is move this line way out and actually turn this into a curve, which is not what we wanted. So I don't know if we can make that edge a corner. Nope. So we don't have the option here really to auto smooth. But instead what we can do is click the node, and we can see this anchor point that's all the way up here. This anchor point needs to be in line with this, so we know we just need to drag it down a bit and do it by eye in this case. Or what we can do is move this node down because it's further away. And let's try the auto smooth again. No. Let's drag this by eye again and check down here. We're getting closer. So we need to move this further down to about here. Keep dragging this out. And we're very close to a smooth edge now. Still not quite there though, so let's drag a bit more. To about here. And out once more. And you can see now there is a smooth edge, or as close to one as we need. And this will drag out that little bit more. And there's the shape. There we go, so it's coming on. Now we need to move this back up because it moved. So we drag this up to roughly there, I'd say. It actually looks like it's moved a few points there. We must have accidentally clicked and dragged a few points when we were doing this. So let's just drag them back into position. Drag this curve in. See if auto smooth works on this. Yes, it does. And on this. There we go. So those two are naturally in line. This one we can drag easily. That's a win. And finally this half moon here. We can drag, say, to the center point first. And then we could slightly go out there. A little bit there. And the inner a little bit in. So I'd say we're there. Ignore that, that's just where the path joins back up. And I think you can visually change the way the path shows this. Once we turn the path into the right object, that will look correct. This now from a distance looks too far over. So bring that over, bring that in a bit. And there we go, looks about right now. So the only thing left on this one is to probably radius this edge, which we'll do last. Radius this edge, we'll do all the kind of smoothing and radiusing last. So this is the D-pad area. We're now going to draw another shape and then we'll combine them after. So we want the circuit board to come up, arc over this ground pad, and then come up here a bit so we can actually put a LED at the edge here. So if we go back to the B tool, we can come inside here because we're going to combine the shapes in a moment. And we want to be roughly on the edge of here. So if we start here at the halfway point of that circle, hold Control to come down and within, it doesn't really matter how far in we go. We'll come arcing over, up, across, maybe over a bit and down here. So let's go to about here, hold Control, go up to roughly that edge there, go over to here, down to, we don't want to go right to the edge because there's a metal cage here. So we'll go to about here. We'll come down to about here, across a little bit, about say there, and then we'll finish the path. We'll change this size to the same. We'll get the tool to bend, and we will do the radius on here. You can see we then just click that, auto smooth, click that, and auto smooth. It will now keep it tangent to the paths, and we know where we need to be in order to get the path to fit right. I think this is actually a perfect one to add a radius to. Instead of a Bezier curve, we probably want a true arc. So if we just undo those curves. So I'm actually going to delete that node, convert that to a corner, get it back, and this one to a corner, just removes all the curves, and I'm going to drag it up roughly to the top like this. Oops. And then instead what we're going to do is we're going to add an arc, an actual radius that's a perfect circle in essence to this part here. That will be easier to control than bending because it's not really a flexible edge. This looks like quite a harsh shape, but this is actually the finished edge. All these edges now, all we need to do is round them. So we'll use the final radius tool to round all those. We'll do the combining into shapes last as well. So this will join and these kind of extra lines will cut off after. So that's one part there. We want to cut out this circle here. So that's nice and simple. Just grab the circle tool, click roughly in the middle, Control and Shift, drag open, and we'll go oversized. There's no point going right next to the edge. And then select the actual hand tool, the S tool, and we can just drag this central over the hole. And there's the hole cut out. And then we want to get to this point on the same circuit board, so we need to get over to here. So another trick we could do is just a rectangle, drag over. We can make it an exact size in millimeters, so here's millimeters. And I'd say we do, I think 2.5 millimeters will be big enough by far for the circuit board. We'll go center over this hole. And then we want to cut out so we can solder through this hole. So same thing again, Control Shift, drag over. And we want to expose about that much. We want to be pretty accurate because the whole point of the circuit board is it will be nice and accurate. Because we want this to be center, you can actually select both of them by just dragging over them or select clicking. So you can either drag over all of them like that, or you can select one, hold Shift and select another. Then if you go to Object, Align and Distribute, you can see we have loads of alignment options here. We want the alignments at the top, not the distribute or rearrange. So it's these here we're interested in. And we want to center on horizontal axis like this. And see how it's aligned with the wrong one? We want to align the other. So Control Z. And then this is relative to here. And you can say last selection, click is wrong, undo. First selection, click. And there we go. We've aligned now this rectangle centrally on the horizontal axis to this circle. So now we can be assured it's a nice circle. We'll do the same here. We'll arc radius these so it's a nice curved edge. And then we'll radius these in so we don't have sharp edges on the PCB. But for now, that's actually all we need to do for the shape. We'll need 4 cutouts for these 4 D-pads because again, that's where the rubber contacts go. So we need to do a shape, and we have here a radius, so that's half the amount. If we do 3 mil, you can see it's actually got to set both of them so it stays the same proportion as a true circle. That looks accurate enough for now. You'll probably find we don't need them to be that far away because the black rubber contact inside here is a lot smaller. So I'll measure the rubbers after and correct this size. But for now, let's actually just change this size, lock the width and height, and let's change this to say 5.5 and then get it roughly center. There we go. Now we could use a pattern tool to do like a radius of these if there was more, but considering there's only 4, I'm just simply going to copy and paste. So Control C, Control V, place them firstly
accurate on the left and right, I'm looking here. And then because these two should be level based on the scan and everything else, we can do the same thing to make them level by clicking the level horizontally. Paste again, align this one here, paste again, align this one here. Now if we select both of them and do the opposite, align on the vertical axis, there's the 4 circle cutouts. So we have it going up to here, we have all the holes here, we have the hole here, and now we just need to do the start and select. So this one's actually a really easy one to do. We just draw a rectangle and make sure it hits all the lines like this. That's pretty accurate. There we go. What we'll do again is the path tool to add the corner radiuses. So these are all just perfect arcs, perfect circles. A circle here for that cutout. We'll go a little bit bigger than what it is, and we'll position it accurately. There we go. We've got this half moon here, which we can chop out as well. So we can do sort of a half moon like this. Position it over the hole like this. And then we need the cutouts for the buttons themselves again. So another circle, and this time we'll do it. Let's see what size we've got. 4mm, let's do 4.5. I'm not sure of the size yet. And then like I say, I'll go and measure the actual rubber sizes and confirm these circles last, but that's an easy last step. Position that approximately, select both and align vertically. And I think that is all we need there. Now we just need to bridge these two together. So before we can really bridge them two, we want to arc this one. So let's just select this rectangle, go to path effects, and this brings up this menu at the side. Click the plus, click corner fillets, and then you can now on this rectangle here, I believe, click the end tool, and now we can click and drag and see how we can make perfect arcs by just clicking and dragging. So if we just click the green, drag, and get it to there, we've got the shape we need. Got one to here. Got one to here. And one to here. And you can see this edge is right near the edge, but that should be fine because the rubber actually hangs over anyway. Now in order to cut this out, we'll select this path and this path. And we will go to path, and then we can choose options here, and they're all different options. By the looks of it, we want to cut the circle out, so we will try exclusion. And you can see that did nothing, so Control Z to undo. Select them again. And it's really a case of really checking. So we'll try combine, and that hasn't worked. So select them again. Try difference, and there we go. You can see difference mode gives us this arc in here. We click the path again. We don't really want sharp edges like this in our PCB. We'll have to re-add the corner option because we've combined the path, so it's flattened it into a non-smart object in a sense. Click the node tool, and we'll radius. See, this corner doesn't want to radius much actually, so we'll click, drag, move that out of the way, move that one out of the way, and now we should be able to radius. Yeah, it's not very good. And that's because we still have this node here. I wanted to move that node. So before we add the corner chamfer, so now we won't corner, we should be able just to move. There we go. So let's just move this further out of the way so we can actually arc this corner. And the same down here. So we probably could have just drawn this circle manually based on how this is going, but that's what you don't know until you try. That should now allow us to, we can probably delete that actually. There we go. Drag this in, put that level, put that level. And we're making an absolute mess of this, making it look far more difficult than it is. I'm just going to delete that curve altogether. In fact, let's just undo that. Go back before we combined, which is here. And knowing that that's going to be difficult to curve, let's just, if we move that half moon over, so this is a different shape technically slightly, but we move the circle halfway past so it's further, and then we make this bigger. So we make the circle a bit too big, but the key I'm after is this point here, this dot of the circle, the halfway center point of the circle wants to be past this line. So when we combine them, we can curve it easier. So if we just do this, say, it's an oversized hole, just makes our lives a bit easier for this quick cutout. We'll do that and that, select these two, do difference, add the path, corner, and let's try again. Nope, and it does not want to do a nice corner there. So instead, let's delete that. And let's go back to the path tool. So instead, if we just go to path, object to path, because this was a rectangle, let's make sure it's an actual flattened path now. And if we do, I think it's Control, Alt, and click, we can add two new points here. Add another one here and another one here. So we've got two kind of paths. We want to do a curve naturally. So we're just going to do this manually. We're going to drag this away a bit, drag this one in a bit, and we're going to do the kind of arcs ourselves. So we'll drag it back there. And now we should be free to arc this in to the rough shape of the hole. And then radius this in like this. And that's what we were after in essence. And we just want this to be bigger. So if we click this node, we should be able to auto smooth. And it really fix the shape to how we want it. So this wants to be a bit bigger than the hole. Bit further out, and I'd say that's the shape we're after. That's a nice smooth shape on the corner there. So that was a bit tricky than I thought, but I'd say that's about what we want. And we've lost this corner here for some reason. Let's do path effects, corner, add that corner back, and there's that shape. And now we just need to join these two together. So we need to put a bridge between here to be able to send the wire down to power these two LEDs. So if we do that, we'll just make, so it's a nice straight line, we'll do a rectangle, and then we'll just rotate it. So if we click the S tool, the select tool, and if we click, I believe, the object a second time, you get the rotation anchor points here. So we can rotate like this, and then obviously make the, click again, reduce in size, and make the bridge something like that. And that's plenty thick enough to get between and to not damage the ribbon if it's too thin either. So I think with that shape, I think we're probably done. Yeah, so that is the shape we need. Let's just start combining these then, because now we need to form a single solid object where it's actually filled with the color of where the actual circuit board is. So these are all independent shapes at the minute. So now let's combine them all together. So this, and this all want to be path union, I'd say. And that's now joined them all together, and you can see it's got rid of the middle bits and formed a single board. The holes then, oh, this one's a union as well first. So let's just do them in sections. That's now added that to the board. Same with this. This wants to be a union to here. And now we have one shape here that if we filled it with something right now, so you can see that's the current shape we have. But we need to put the holes in. So now I think the simplest way is select everything, because all that's left is holes. And if we do path and maybe, I think it's usually combine maybe, and now we fill it. There we go. You can see now we've got a fill. and that actually, let's leave it filled and do a partial transparency. That's a good way of viewing it. So now here's the final shape we're looking at the minute for this board. And as I mentioned, the last thing we want to do is add the smoothing radiuses to all the corners. So like these sharp edges, we don't want any real sharp edges. So to do that, it was the path effects, add, and corner. I don't know whether we had that selected when I did that, but we'll see. Click the N tool. Yeah, we did. And now we can start just clicking the corners and smoothing them off. And I'm not too worried about like the specific size of the radiuses, just tend to try and get them matching either side. But because this is just a visual thing for the board and not anything mechanically required, we've got a bit of flexibility on, you know, the shape and size of these radius. So just clicking and dragging is fine. This bit will smooth just again a little bit, just to get rid of any kind of sharp edge. You don't really want any sharp edge on a PCB if you can help it. So we'll just round them all off. This one we mentioned originally here, we can bring down. So we'll bring it down probably, yeah, there's good. So it's going to be more rounded than the board, but that's fine. And then this edge, again, this is a very sharp edge. Let's just bring that in, something like that. These edges, we might as well also add a little bit of extra radius. So it's just a nice smooth board. And then here, same again, curve up. Oops, get there in a minute. There we go, edge on here. We'll smooth this bit. We'll smooth the edge there. This bit we possibly want to leave as an actual sharp edge because this is going to run down the edge of the metal and the LED is going to be positioned probably right on the edge of this board so that it's as close to the trigger as possible. So we're going to leave that one sharp. This one, no real need to be sharp. And this one now, to get that nice edge around there. And bear in mind, we're going to be soldering here. So this is the anchor point we want. So actually, we probably want to leave this smaller, just a tiny radius. Like that. Because we will want to get some solder into this pad here. So I'd say that is good so far. Same again here. Radius. You want to be almost the full halfway here, like that. Yep, and now you can see we've got a nice easy pad to solder through there. And then finally, I think that's it. We've gone all the way around the board. Yeah, so there is our, if I can get to the colours, fill it full. There is our first PCB, that side. The other side's exactly the same, so I'm not going to bore you drawing that side. I'll just draw that side and show you the end result. But it's basically the exact same principle as we've just done here. And so here's this side drawn, the shape. You can see we've gone up here the same. And I've just started to add the corner radiuses. So just finish this board off here. And you can see I've gone over here to the S2. So I've just creeped over from this edge here. I've come along, and bear in mind there's a capacitor here, C7. So I've gone around that, otherwise we'd sit on top and it wouldn't be as nice. So I've just done a little bit of a sort of sweep around that capacitor there. Don't need to worry about this test point. We're going to have no exposed copper shorting out or doing anything different there. So it's fine that we're going over that pad. And then here I've pre-cut out. You could leave it flat and go halfway. I wouldn't recommend going fully over a big pin like this because there's no need. You can just half moon it and it's easier to remove after. You could also do this in your end PCB software. You could just put a through hole here and it would naturally cut out. But just for visual and for easier reference, I thought we might as well add the actual sort of cut out here so you can tell where it's meant to be. So I've added it at this point. And you can see here, even the most complex looking shapes are just as easy to draw. You just you break it down into the lines that are making up the shape, into corners and straight lines, perfect circles and arcs, or curves. That's really the only three things you kind of break the board down into. And I think that's it. So if we fill that in, and I think there we now have both board shapes. We have to have the cutout here, actually, saying that. Forgot the button cutouts. I think those are the same as these cutouts, which you'll see now when they're combined as well. The reason you combine last is because you can't easily change this shape now here. As such, it's now a sort of a combined shape. So making that circle different, you'd have to delete it all from, say, the actual original shape, and then you'd have to re-add it and combine. Whereas if it was a single shape still exposed, you could just resize it. So I think we did them 5.5. I think it was. So let's just chuck in another one here. And I think these, if I remember rightly when I measured before, these would actually cut into, yeah, it wouldn't be that small, maybe 6. It would cut into these curves. So I think it's still 6.5. I think we've got it a bit too small. Yeah, so I'm pretty sure these come out from where you could be in. So I'm going to leave them at 6.5 and center it based on this edge here and this edge here as being the kind of half moon. So you can see covers there, and you've got about the same exposed all around. So centrally that looks okay. Copy and paste that, position this one, and over there and there roughly. Yeah, I'd say about there. And now because this is already a fully combined shape, we would lose the ability to tweak the corners now because I haven't put the cutouts in the first place. So like this corner effect that you can hide and show, that sort of hides and shows the corners. Because I forgot to put these circles in here, when I add these together and do path combine, you'll see now the path effects have gone. In fact, it's actually lost the path effects there, which is not what I wanted. So before we do that, so you don't lose the path effects, let's just do path. And I believe it is it simplify? No. Is it path object to path? There we go. And now it's kind of committed the path effects in and the part of the path itself. So we can select these corners, but we can't now just drag them independently. But because I'm fairly happy with the shape and I'm not really too fussed about that, that's fine. It only took about 3 or 4 minutes to draw anyway, so it's not really a problem. And then path combine, and let's take a look at the path now. And there we go, I've remembered this time. So that looks like the shape of our boards. We hide that out of the way. This is now what we're looking at to produce, so I'll just save that file. This will form our actual circuit board now, so I'll have 2 circuit boards. One picks up ground here and gets 5 volts from here. The other picks up ground from here and gets 5 volts here. And now we can put LEDs around this button, all 4 D-pads, both triggers, and start and select. So that's all there really is to the circuit board design. So the next step now is to cut these out and overlay them on a real circuit board in real life and see if the shape matches. Because we're using high-res scans that I've made that I know are accurate, these should cut out and position perfectly. But I'll show you how to do that next, and then we'll go on to the actual circuit board design.